Most people assume that sleeping less than 6 hours simply leads to feeling tired the next day. We view sleep loss as a transaction, time traded for productivity, paid back with a coffee or a nap. But what actually happens inside the body is far more complex and far more cumulative. Short sleep does not only affect energy levels, it fundamentally alters how your biology operates at a cellular level, from the molecular cleaning systems within the brain to the regulation of genetic expression. The absence of sleep triggers a cascade of physiological adaptations. The body does not simply wait for you to wake up. It actively engages in repair, memory consolidation, and metabolic calibration. When this window is consistently shortened, these processes are interrupted. In this video, we explore the physiological reality of sleeping less than 6 hours. We will examine the mechanisms of the brain, the shift in hormonal baselines, and the silent accumulation of what scientists call allostatic load. This is not about feeling tired. This is about how the human body maintains its existence over time. In modern society, the definition of a normal night's sleep has shifted. Evolutionarily, human biology is designed to align with the solar day. However, extended work hours, artificial lighting, and constant digital stimulation have decoupled our behavior from our biology. Sleeping 5 or 6 hours has gradually become a standard routine for many. The dangerous aspect of this shift is not the immediate exhaustion, but the body's ability to mask it. The human body is highly adaptive. When sleep is restricted, physiological systems temporarily compensate to maintain alertness. Stress hormones like cortisol and adrenaline increase to bridge the energy gap. This creates a state of tired but wired. Subjectively, an individual may feel functional. They may believe they have adapted to a 6-hour cycle. However, clinical data suggests that while the feeling of sleepiness may plateau, cognitive performance and physiological health continue to decline linearly. Adaptation is an illusion. What is actually occurring is a shift in baseline functioning, a new normal where the body operates under constant, low-grade friction. Perhaps the most critical process disrupted by short sleep occurs within the brain itself. For decades, scientists questioned why all species sleep. Given the evolutionary risk of being unconscious, the answer lies in a system known as the glymphatic system. This is the brain's macroscopic waste clearance mechanism. During wakefulness, brain cells are highly active, metabolizing energy and producing cellular waste products, including proteins like beta amyloid and tau. While awake, these byproducts accumulate in the space between neurons. It is only during deep, slow-wave sleep that a physical transformation occurs. Glial cells, the support cells of the brain, shrink in size, effectively increasing the space between neurons by up to 60%. This allows cerebrospinal fluid to flush through the brain tissue, washing away the toxic proteins accumulated during the day. When sleep is restricted to less than 6 hours, this cycle is cut short. The flush is incomplete. Imagine a cleaning cycle that is stopped halfway through. Some waste is removed, but a residue remains over days, weeks, and years. This residual accumulation interferes with neural communication. It creates a biological environment associated with accelerated aging and reduced cognitive clarity. The brain does not stop working, but the biochemical environment in which it operates becomes increasingly polluted. Beyond waste clearance, sleep structure dictates emotional and logical regulation. The brain relies on a strong connection between the amygdala, the center for emotional reactivity and threat detection, and the prefrontal cortex, the center for logic and impulse control. This connection acts as a brake. The prefrontal cortex regulates the amygdala, keeping emotional responses proportionate to the situation. Sleep deprivation weakens this connection. Without sufficient REM sleep, the prefrontal cortex loses its ability to dampen the amygdala's activity. The result is a brain that is hyperreactive. Minor frustrations trigger disproportionate stress responses. Focus drifts. Decision-making becomes more impulsive and less calculated. This is not a personality change. It is a mechanical failure of neural inhibition. An individual sleeping 6 hours or less may not notice a sudden drop in IQ, but they will experience a reduction in executive function, the ability to plan, regulate emotion, and foresee consequences. The impact of short sleep extends far beyond the brain, deeply influencing the body's metabolic machinery. Sleep is a primary regulator of the endocrine system. When duration is shortened, the body interprets this as a state of metabolic stress. One of the first systems to be affected is glucose regulation. Studies indicate that even a few nights of restricted sleep can induce a state of temporary insulin resistance. Cells become less responsive to insulin, leaving glucose circulating in the blood rather than being efficiently absorbed for energy. Simultaneously, the hormones that control appetite are disrupted. Leptin, the hormone that signals satiety or fullness, decreases. Ghrelin, the hormone that signals hunger, increases. This is an evolutionary survival mechanism. If you are awake longer, the body assumes you need more energy to sustain activity. However, in a modern context, this leads to a subconscious drive for high-calorie, quick-energy foods. The body is not just tired, it is biochemically confused. It shifts into a mode of energy conservation and storage. Metabolic flexibility, the ability to switch efficiently between burning fat and sugar, is compromised. Over time, this accumulation of metabolic inefficiency places a silent but significant load on the cardiovascular and organ systems. A common misconception is that sleep loss can be recovered quickly, that a good night's sleep on the weekend fixes the deficit of the week. Physiologically, this is inaccurate. While subjective sleepiness may decrease after a recovery night, deep systemic markers often take much longer to return to baseline. This concept is known as allostatic load. It represents the cumulative wear and tear on the body caused by chronic exposure to fluctuating or heightened neural and neuroendocrine responses. When sleep is consistently short, the baseline for stress activation rises. The sympathetic nervous system, the fight or flight mechanism, remains slightly overactive. Heart rate variability, a key marker of recovery and resilience, often suppresses. The body is effectively running an engine at a higher RPM while idling. This creates a feedback loop. The elevated stress state makes it harder to enter deep, restorative sleep, which in turn leads to less recovery, which further elevates the stress baseline. This cycle can persist for years, often labeled simply as aging or stress, masking the root cause of the physiological strain. When we look at the data on longevity and health span, sleep acts as a foundational pillar. It is during sleep that DNA repair processes are most active. It is during sleep that the immune system produces cytokines required to fight infection and inflammation. Consistently sleeping less than 6 hours compromises these maintenance protocols. It is important to understand that biology operates on thresholds. The body is resilient. It can handle acute periods of sleep loss. But when the deficit becomes chronic, resilience erodes. The buffer against stressors, whether physical, mental, or immunological, thins. Recovery becomes slower. The system becomes fragile. Understanding this is not about fear, but about recognizing the biological cost of our daily choices. Sleep is not a passive state of rest. It is an active, metabolic, and neurological state of reconstruction. It is the only time the human body can fully service the machinery that sustains life. Prioritizing sleep duration is not merely about energy for the next day. It is an investment in the long-term integrity of the human system. This is the baseline of human recovery.